Just as we discovered for addition, we can also use that property with a subtraction. So does it surprise you with multiplication that maybe we can also use division in the same type of way? So let's imagine we have 6x equals 30. I want to find out for what x this is true, but we're going to use our process. So can I divide both sides maybe by a number to isolate the value of x, or the variable of x? If I divide both sides by a 6, and remember, I have to do it to both sides in order to maintain the balance. Then on the left side, I see my 6's. That's a clever version of 1, so I can factor them out. And I'm left with x equals 5. Did you also notice too, and this might be a good time to remember how multiplication and division are similar. So let's go back and look at 6x, or 6x equals 30. I divided both sides by 6. Well, that's similar to doing the same thing by multiplying both sides by 1/6. See that? Dividing by 6 is the same thing as multiplying by 1/6. Because if I multiply this out, I will then get a 6x over a 6 equals a 30 over a 6. And then x equals 5. So just a little reminder that multiplication and division are essentially the same thing. Dividing by 6, same as multiplying by 1/6. Another example, minus 7y equals 56. I want to isolate the variable y. Where the variable is, in this case it's y, I want to isolate it. So to do that, I want to think of a great number, divide by, so that the y is isolated. And I'm going to divide by -7. To do that, I have to do it to the other side as well. And then I'm left with the -7's factor out. I'm left with the y equals 56 divided by -7, a -8. And it's all right if I have negatives. Negatives is just another number that we want to be able to work with. So in this case, I divided by a -7 so that I'm left with a positive y. If I just divided by a 7, so let's go back and say -7y equals 56. If I just divided by a 7, which I can do, may not be the best choice, but it's still a good choice, that produces a -y equals an 8. This is not a solution. The solution has to be terms in a positive y. So I need to figure out how to get rid of that negative, and that's where I can multiply both sides by a -1, and that will resolve that issue. Let's look at one more example here. -18.9 equals 3z. Our goal, we can work with decimals. I want to remove this 3. Well, actually, I kind of want that 3 gone, so it's just a z. So what are we going to divide both sides by to do that? I'm going to divide both sides by a 3. And that remains on the right side. What I'm left with is I'm left with a z. And on the left side, -18.9 divided by 3 gives me a -6.2. And there's my solution. Doesn't matter the variable, doesn't matter if the number is a whole number, a decimal, or even a fraction, which we'll deal with down the road. Doesn't matter. I can use multiplication or the multiplication property of equality to help isolate the variable, which leads me towards the solution of the particular linear equation.